Hello everyone. In this presentation, we are covering the third basic operation of the matrices, which is really important. Just to be sure, the previous time we are looking at the scalar multiplication and matrix addition and subtraction. In the scalar multiplication, we are just multiply the scalar number with the each cell of a matrix, and matrix addition and subtraction, we have just one condition, which is the matrix dimension should be matched in terms of if you have a matrix 2 by 2, there should be another matrix 2 by 2 so that you can make addition or subtraction. If it is 3 by 3, you have to need a 3 by 3 matrix as well. Okay, and we introduce an identity matrix, and then if we try to add something like 2 plus a matrix, before making an addition, we have to multiply the 2 with an identity matrix. Remember, the identity matrix have such a system, such a cell system 2 by 2 volume for 2 by 2 matrix addition, and you are just going to multiply with the 2, then or 4 or 5, or just call this number an alpha and then make addition or subtraction. Anyway, we just covered them the last time. Do not need to worry if you do not understand very well. After this presentation, we are going to solve some example question to go over them, and some tricky question I will introduce you when I am also encountered in the exam and confused at the exam moment. Anyway, the third one is a matrix multiplication, dot product. I mean, this is really most important thing, and most of the time in the exam, the students come through all the steps successfully, and when the matrix multiplication have to be done, they are making mistakes, and this really affect their point, because without a correct answer in the engineering faculties, they giving a 0 point, unfortunately. Okay, so for the matrix multiplication, we have a 2 matrices. Okay, start with the 2 matrices. For first matrices, let's say that it's an n by n dimension matrix, and for the second matrices, let me say I will make another introduction. Let's say A times B, let's say C times D. There's a first condition before doing a matrix multiplication. First, be sure you write your dimension at the bottom of your matrices. Okay. The second one, dimension should be matched. Dimension should be matched, but how? Dimension should be matched. Okay, this is really important. In terms of what? For example, you have to have B equivalent to C, certainly. And you do not need to worry about anything at all. And A do not have to equal to C, equal to D, sorry. Okay, but B have to be C. Okay, they have to be same. I will come to the reason while making a simple example. Let's make this is a 3 by 4 matrix. I am going to start with a simple example, sorry for that. Let's start with a 2 by 2 matrix times with a 2 by 2 matrix. So B and C are matching. There's no problem. There's no violation to make a matrix multiplication. And I am writing just a random values. Okay, the rule is that after you are looking at B and D are matching, B and C are matching, ignore them and take A and D for the resulting matrix dimension. Okay, I'll come to the reason. Do not worry about that, but remember this. Okay, so how this magic is happening? You are taking first row of a first matrix, and you are taking the first column of a matrix, then apply a dot product. What was the dot product? Just you are going to multiply each element with each element. Okay, so you need to do that for this one. 1 times 5 plus 2 times 7, which is resulting 5 plus 14, which is 19. Okay, and I am looking at the second element, second cell. For the second cell, what I need to do, you take the first row again, but you are going to take the second column. Okay, and this is 1 times 6 plus 2 times 8, which results in 6 plus 16, 22. Okay, so to make sure you understand its theoretic logic itself, there's a notation most professor and teacher use it in. This is the element, the cell, first column in a first row. The element is the first row but second column. But as you can see, this is the row 1, this is the row 2, this is the column 1, this is the column 2. Okay, so if you are looking at this element, this is in the second row and the second column. Do not confuse about this notation. Okay, I am going through it. I believe you got idea, but I am going to do that. The second row and the first column, in this new notation, this is it, A21 equal to, let us write together, 3 times, what is it? Okay, 5 plus 4 times, what is it? 7, which is equal to 15 times 28 and 43. Okay, so it is the last time the second row and what is it? Second column. Let's do it together as well. 3 times 6 plus 4 times 8, which result in 18 times 32, 4, 50. As you can see, there's no big deal in here. No dimension check required because you got 2 by 2 matrix, you multiply them, you got 2 by 2 matrix as well. But what if we change the matrices in a different example? Let me write it down. Okay, 3 times 2 matrix times 2 by 4 matrix. Okay, so we need to be careful. In this matrix, we have 3 rows and 2 columns. So let's write the 3 rows and number itself. Oh, I made a mistake, sorry. Do not memorize things, okay. There's a 3 row. Let's always, I am showing in this notation so that I do not forget anything at the beginning, but in the exam, just do not do this. And this is 1, 2, 3, 4, 5, 6. This is a 3 by 2 matrix. And let's write a 2 by 3 matrix. Okay, we have a 2 row and 4 column. Let's write the number in a corresponding way. Okay, and we need the resulting matrix. I am go through it. We memorize that if this part is this B and C are matching, the resulting matrix is 3 by 4. But we can prove it easily by looking at this. As I introduced previously, we are taking the first row of a first matrix and we are just making dot product with the first column of a second matrix, right? This gives a 1 element. And for each row, we have 4 what? Column. So for each row, we have 1, 2, 3, 4 element, right? And for second one, we have as well, for one as well. And for the third one, we also have 4 resulting cell. Okay, I am just closing this part and please say to me, what is the dimension of this red part matrix? It's actually how many columns? 1, 3, 1, 2, 3, 4. How many rows? 1, 2, 3. So 3 by 4. Oh my goodness. So we just multiply with the 2 by 3 matrix and 3 by 4 matrix and we result in 3 by 2 matrix as well. And it totally makes sense according to what I introduced you. Okay? This is a matrix multiplication. You do not worry about that too much. I will solve as many questions as possible in the next presentation. I know it's things not clear right now, but in the next presentation, I assume that everything will be much more clear. See you in the next presentation and think about what I am introducing in here, but do not worry, in the next presentation I also say what I am saying in here as well. See you in the next one.